Hey guys, hi, hello, namaste, adab, sat sri akal, assalamu alaikum, vanakkam and khamba kani to all of you. Welcome to today's class. कैसे हैं सारे बच्चे? How's everyone doing? Awesome, wonderful. क्या हाल चाल? Alright, so welcome to today's class guys, and as you all know, this is your CBSE 9 under Prodigy series, and the topic we will be discussing today is your polynomials. All right, so we are starting a new chapter. I hope all of you are very excited, and those who are excited, which do let me know in the comment section, do let me know in the chat box that yes we are super duper excited. All right, and just give me, how's the Josh? Is the Josh high? Just give me a thumbs up. Just give me a thumbs up in the live chat if you think that yes sir, Josh is high, we are ready for the new topic, that is polynomials. Alright guys, now before I start the topic, let me tell you very clearly that this session is really very important. This topic is really very important because in this topic what we are learning polynomials, it will be useful in our grade 10th, it will be useful in our grade 11th, it will be useful in our grade 12th. It is what we are learning in this is the basics of polynomial, and which will be our basics for the algebra questions. In the algebra, polynomials will be playing a major part. All right, so it is going to be the basics for our upcoming grades. So very important that you be very good with this chapter. You really have to be very good with this chapter. All right, so let's start the class. I hope all of you are amazing and awesome, and let's start this amazing class. And I hope you are giving me thumbs up in the chat box. All right, so let's first start the class. This is what the topics beta we are going to study. So the first session, this session I have made it for introduction and zeros of a polynomial. This is the only topic which we are going to study in today's class, because in the introduction there are many terms, many terminologies are there which we need to be careful, and which we need to understand the meaning as well. All right, we need to understand its meaning. Second is your remainder theorem. Third is your factor theorem. So once we will be able to remember remainder theorem, after that factor theorem will be easy. And in factor theorem we have some very good questions which are related to the factorization. All right, we'll be understanding factorization in detail, how to factorize different types of equation and all those. Then comes your algebraic identities. So till now beta, you, I think in your grade 8 you have studied three identities which were like a plus b whole square, a minus b whole square, and a plus b into a minus b. These three you have studied. Now we will be studying some more algebraic identities, and these identities also are very important, and I'll tell you how these identities came at simple multiplication of the polynomial. So we are going to learn everything in detail. I hope all of you are ready. All right, so let us start today's class. All right beta, also one more thing, when I will be doing the remainder theorem, as you have already learned about the addition and subtraction of the polynomials, all right, and multiplication also you have learned, and as well as division. So multiplication, subtraction, division and addition, all these four things we have learned in grade 8. If you all remember, division of polynomials you have learned, multiplication of polynomials you have learned. If not, division will be covering in the factor theorem. Multiplication, addition and subtraction is comparatively very easy. All right, okay. So let us start the class. So first thing beta is polynomial. What is the meaning of this chapter? Polynomial means poly. It is a mixture of two words, poly and nomial. Poly means many, nomial means terms. So there will be many terms, as simple as that. There will be many terms. So it says many terms. Polynomial means many terms, but it can also be one term. By simple things, there will be some terms. Many means it does not mean every time many terms only. It can be one term also, but you can understand an algebraic expression with one or more terms, but there are some more conditions as well. So first thing we got to know that an algebraic expression with one or more terms, there should be one or more terms. All right. After that, the next thing. So this is the polynomial. Now what is the definition of it? How it is different from algebraic expression? So understand beta, bhai dekho, algebraic expression is like say a big Gaussian, or algebraic expression is suppose this big circle. So inside this big circle, if I write all the expressions, inside this big circle, if I write all the algebraic expressions, suppose it is algebraic expression, all right, then only some portion of this will come under polynomials. Only some portion of algebraic expressions will come under polynomials. Not all algebraic expressions are polynomial. Please understand, it is a very, 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 very important thing. It is very important thing. Not all polynomials are, not all algebraic expressions are polynomials, but all polynomials comes under algebraic expression. All right. So algebraic expressions, we have learned about them. All right. So under that we will get some polynomials. Now how do we know that whether a given expression, whether a given algebraic expression is a polynomial or not? So the condition very easy, beta. The conditions are very easy. It's as simple as that. First thing, we need to make sure that power of the variable in an algebraic expression, for a algebraic expression to be a polynomial, the power of the variable must be a whole number. The power of the variable, be very sure I am talking about power of the variables, must be a whole number, or variables have whole number exponents. Variable should have whole number exponent. It means I am talking about the power of the variable, not about the numbers. Numbers can have any power they want. I am not caring about them. I am only saying power of the variable must be a whole number. Whole number means it can be 0, it can be 1, it can be 2, 3, 4, like and so on. But remember, that means power, we can say it must be only whole number. So power cannot be negative, power cannot be fractions, all these things. All right, 1 by 2 not allowed, 3 by 4 power not allowed, minus 2 power not allowed, only whole number powers. Next thing, variable and no variable appears in denominator. That means division by variable is not allowed. Division by variable is not allowed. So only these two things, beta, you need to take care of. See, when the variable is in the denominator, we can say its power is negative. In a way, its power is negative because it is in denominator. All right. So two important conditions, beta, you need to remember, that power of variable is whole number. This is the first condition. And please guys, please, yeah, make sure you understand this thing. I'm talking about power of the variable. All right, power of the variable is a whole number. And the second thing is what, beta? Division by variable is not allowed. Division by variable is not allowed. All right. Okay, so you can see in the first one, beta, in the first one, I can see there are different terms, and in all the terms, the power of the variables are whole numbers. Also, in this constant term, when I write 3 only, na beta, power of the variable over here is 0. Power of the variable in a constant term is 0. Why? Because I can write 3 as 3 into 1. Yes or no? And 1, I know anything raised to the power 0 is 1. So I can say 1 can be written as x raised to the power 0. Any variable raised to the power 0, whatever variable we are using in that equation. So I can say this 3, when the number is constant, the variable is hidden with power 0. The variable is hidden with power 0. That is why we have told whole number powers, because 0 also we have included. 0 also we are considering. Alright, now here see, power of y is minus 2. That is why it is not a polynomial. Here x is in the denominator, it is why it is not a polynomial. Alright, so these are some examples of your polynomials. So just remember these two conditions whenever the question comes, that find out whether the below given polynomials, the below given expressions are polynomials or not. Just use this. All right. Okay. Next question now. Polynomials in one variable. So polynomials in one variable means, beta, in that variable only in that polynomial only one variable will be there. For example, here if you'll see x and y, two variables are here. But here if you'll see t square plus 6t minus 9, only one variable we have. So that is polynomials in one variable. Now classification by number of terms. To understand guys, if we have suppose only one term, we'll call it monomial. If we have two terms, we'll call it binomial, and three terms, we'll call it trinomials. Remember beta, number of terms, if I'm counting unlike terms. Unlike terms means I cannot add or subtract them further. You cannot say, sir, x plus x, sir, it is a binomial because two terms, x and x. No, it will be monomial because I can add them further. So it is a monomial. But if I give you suppose x plus x cube, now you cannot add these two. So now I can say it will be binomial. Alright. So if there is only one term, monomial, two unlike terms, binomial, three unlike terms, trinomial. If more than three terms are there, in that case what you'll call, so we don't have any special name, call it normally polynomials. Alright, just normal word, normal term, polynomials only. Simple, known other name. But very important, it does not mean that monomial, binomial, trinomials are not polynomials. See beta, I am saying polynomials definition I have given you over here. So it does not mean in a polynomial there should be more than three terms only. Nahin, monomial is also a polynomial, binomial is also a polynomial, trinomial is also a polynomial. But if there are 4 terms or 5 terms or 6 terms, so in that case we don't have any special name. Alright, suppose you know me. If I'm going on the road and you saw me, you'll call me, yeah, hi Gopal sir, hello, because you know my name, you'll call me by name. So monomial, binomial, trinomial, I have given them their name, so I can call them by name. But it does not mean that I am not a say boy. I am a boy as well. Alright, I am a male. So I am male also. Suppose you are going on the road and you want to call someone. Some other person is going there, so you will call them, hello bhaiya, please listen, bhaiya suniye jara. When you go to a shop, you don't know the shopkeeper's name, so you'll just call simple bhaiya. It does not mean his name is bhaiya only. Alright, you're just calling him that. Same way, if there are more than 3 terms, the name is not there. That is why we only call them polynomials, because there is no other name. Understood? So monomial, binomial, trinomials are also an example of polynomials only. But if more than 3 terms are there, there is no specific name for them. We don't have any specific name. And especially we are studying maths. We are not here to remember the names. Alright. Next, degree of a polynomial. So beta, first classification, this is type 1. One type of classification. First type of classification, that is on the basis of number of terms. So on the basis of number of terms, we have monomial, binomial and trinomials. And if more than that, simple polynomials. Nothing else. Next is your degree of polynomial. Now what is the meaning of degree? For example guys, let's say I'll give you an example. Okay, so I am giving you 6x cube minus, we'll generally restrict it to the one variable only. Alright, minus 5x plus 6x minus x raised to the power 7. This is raised to the power 5. This is a polynomial we have. Or chalo, let's say this is an algebraic expression. Guys, let me know in the chat box, this algebraic expression which I have given to you, is it a polynomial? Yes or no? First tell me, is it a polynomial? I am staying for 10 seconds. Do let me know quickly in the chat box, is it a polynomial? Yes or no? Yes or no? Be quick. Alright, so I hope many of you are giving me the correct answer, and it is yes sir, it is a polynomial. Because if I look at the power of the variable, first thing, division, in division there is no variable. Alright, second point is clear. Let's look at the power of the variable. Here power of the variable is 3, here power of the variable is 1, here power of the variable is 5, and here power of the variable is 7. I am not looking at the power of the coefficients. No, only power of the variable. So power of the variables 3, 1, 5, 7. All these are whole numbers. Yes, sir. All the powers are whole numbers. So it will be a polynomial. It is a polynomial. Now I can say it is a polynomial. Okay. Now talk about degree. So beta, degree, what is degree? degree is the highest power of the variable. In the given polynomial, whatever is the highest power of the variable, that will be called the degree of the polynomial. So out of 3157, highest power is 7. Highest power is 7. So we will say degree of this polynomial. Degree of this polynomial is 7. A degree of this polynomial is what, beta? Degree 7. So 6x square has degree 2. Now suppose, for example, if there are two variables, say 4x square into y cube. In one term, there are two variables, 4x square y cube. And if I ask you what is the power of the variable in that term, so in this case, beta, since both x and y are variable, you will add the powers of both. So power of x is 2, power of y is 3, add 2 plus 3 is 5. So power of the variable in this term will be 5. Okay? If there are two or more variables, they are in multiplication, add those powers. Alright. So degree of the polynomial is the highest degree of its term. Alright. Now on the basis of degree of the polynomials, beta, we have some classification. The first classification, constant polynomials, that means degree 0. Degree 0 will be your constant polynomials. In constant polynomial, there is one extra case as well. There is one extra case in constant polynomial, which is zero polynomial. In zero polynomial, the degree is not defined. Alright, this is an extra case. Zero polynomial, in zero polynomial, degree is not defined, and zero polynomial is defined as px equal to 0. Other than 0, if there is any other number, then it will be a constant polynomial of degree 0. If other than 0, any other number, any other non-zero number, any non-zero real number, if I make it equal to a polynomial, then I will say it will be a constant polynomial of degree 0. And if the number 0 I will say it is a zero polynomial. That also, zero polynomial is also a constant polynomial, but there is a special category inside constant polynomial, which is zero polynomial, and in this case degree is not defined. Okay, beta. Then comes linear polynomial. So linear polynomial, beta, will be degree 1, quadratic degree 2, cubic degree 3, and biquadratic degree 4. Alright. Acha, here this coefficients, I need to write it correct. A, B, C, D, all has to be different, right? A, B, C, D, E. Alright. Okay. So देखो बेटा, by every case if you'll see, when constant polynomial is there, there is only one term which is a constant number. So power of the variable is 0, and that only is the highest power. Here highest power is 1. So it is a linear polynomial. Here highest power is 2. It is a quadratic polynomial. Highest power is 3. Cubic polynomial, highest power 4. Biquadratic polynomial, and so on. But see, even after that, there are some names, but no need to remember it. Only up to cubic is also sufficient. Understand the difference? Constant, linear, quadratic, cubic. These four things, if you'll understand the difference, constant, linear, quadratic, and cubic. So these four, once you'll understood, everything will be easy for you. Alright. So this is what classification on the basis of degree of polynomials. So I have told you zero polynomial as well, and I have told you the degree of a zero polynomial is not defined. Now you might ask me that, sir, what happens if you are saying that px equal to a, where a is any non-zero real number? In that case, degree is equal to 0. But if I make px equal to 0, you will say degree is not defined. What actually happens, sir? What happens with 0? Suddenly what happens to you that with 0 you'll say degree is not defined? What is the special case about 0? So let us understand it. Let us understand within the example. Alright, let's take a number 2. Any non-zero real number, let's say I have taken 2. And here let's take the number 0, with which we have to see now. Now see beta, I will write different terms of 2 with different powers of x, and let me see whether you are able to identify them or not. When I write say 2, you know in this case power of x is 0. By 2 I can write as 2x raised to the power 0. Yes or no? Suppose if I multiply 2 with x raised to the power 0, it will be 2 only, 2 into 1. If I multiply 2 with x, you will get 2x. If I multiply 2 with x square, you will get 2x square. If I multiply 2 with x cube, you will get 2x cube. Alright, and so on. So by looking at the term, you can definitely say what will be the z power of the variable if I use a number 2 or 3, anything. So when I say px is equal to 2, when I say px is equal to 2, you are pretty sure in this case power of the variable is 0. And this is the highest power, so degree will be equal to 0. That is why we have called it a constant polynomial. Now uses the same thing can be done also now. If I say px equal to 0, I can say 0 into x raised to the power 0 is same. Can be said, but just look at this over here. If I multiply 0 with x raised to the power 0, my answer is 0. If I multiply 0 with x raised to the power 1, my answer is again 0. If I multiply 0 with x square, my answer is again 0. If I multiply 0 with x cube, my answer is again 0. If I multiply 0 with x raised to the power 4, my answer is again 0. And every time, no matter what power of x I will multiply 0 with, my answer is always 0. Alright. Now beta, if I tell you that chalo, px is equal to 0, I have given you. And I tell you beta, tell me the highest power of x over here. So one of you told, sir, 0, it is nothing but 0 into x raised to the power 0. Because 0 into x raised to the power 0 is 0 only. Okay. I'll say very good, बहुत अच्छे. One more student will come, no, sir. Why only x raised to the power 0? I think this 0 is 0 into x. I can say, yeah, that is also true. Then one more of you will come, nahi, sir, it is 0 into x square wala 0. I know this is yellow, that is why it is. Some of you will tell and come me, sir, it is 0 into x cube, then it is 0 into x raised to the power 4. So at the end, I know all of you are saying correct. It can be 0 into x, 0 into x square, 0 into x cube, 0 into x raised to the power 4. It can be any power. So I don't know which power of x I am multiplying here. But in this, I am pretty sure I am multiplying 2 with x raised to the power 0. Because if I multiply 2 with any other power of x, my answer, my term will automatically change. That is why in case of 0, we will say degree is not defined. Degree, that is why we will say degree is not defined. Alright beta, ठीक है. Very important topic, why degree of a 0 polynomial is not defined. Because when I write px equal to 0, we cannot say for sure that 0 is multiplied with what power of x. We cannot say it for sure. Alright, okay, next topic, very important topic, which is called zeros of a polynomial. You will be thinking, sir, what it is? What zeros of a polynomial? Alright, zeros of a polynomial beta, very easy concept. I give you any polynomial. Let's say I have given you any polynomial px. I have given you a polynomial px. Now, this polynomial px will have different values at different values of x. For example, let's take an example. Let us solve it with the help of one example. Alright, let's say I have a polynomial px. This is how we write a polynomial. P of x means this is how we write a polynomial p of x. So let's say I have taken a polynomial p of x, which is, let's say, 2x plus 1. This is a polynomial p of x, which is 2x plus 1. You already know what are the values of polynomial. है ना? But for different values of x, I will get different values of polynomial. For example, let's choose the values of x and let's see what are the values of polynomial. If I put x equal to 0 beta, suppose if I put x equal to 0, what I will get? I will get 2 into 0 plus, or make it 2x plus 2, better it is, 2x plus 2. So if I put x equal to 0, 2 into 0 is 0 plus 2, value of polynomial is 2. If I put x equal to 1, 2 into 1 is 2 plus 2 is 4. If I put x equal to 2, 2 into 2 is 4 plus 2, 6. Yes or no? Correct? So you can say for different values of x, the polynomial is getting different values. So 0 of a polynomial is that value of x. the value of variable, the value of variable for which the value of polynomial becomes equal to 0. The value of polynomial becomes equal to 0. For example, let us say, alright, let us say कि this polynomial 2x plus 2 is given over here, beta. Alright. Okay, wait a second. Just let me use some more space. है ना? For example, as you all know, beta, value of a polynomial. So for this polynomial, we have seen its value at x equal to 0. So p of 0 means value of polynomial at x equal to 0. What do we say? P of 0. It means value of polynomial px at x equal to 0. So it will be equal to 2 into 0 plus 2, which is equal to 2. So p of 0 is equal to 2. P of 1 is equal to 2 into 1 plus 2, which is equal to 4. P of 2, value of a polynomial px at x equal to 2, will be 2 into 2 plus 2, which is equal to 6. So different values of x, we are getting different values of the polynomial. Alright. Now let's put x equal to minus 1. So in this case, what will happen if I put x equal to minus 1? So p of minus 1 will be equal to 2 into minus 1 plus 2. 2 into minus 1 is minus 2 plus 2, which is equal to 0. So you can clearly see, beta, at x equal to minus 1, value of polynomial px is equal to 0. At x equal to minus 1, value of polynomial is equal to 0, p of minus 1 equal to 0. So I can say x equal to minus 1 is a 0 of polynomial px. Value of the polynomial px at x equal to minus 1 is equal to 0. So x equal to minus 1 will be called the 0 of the polynomial. So 0 of a polynomial means that value of the variable for which value of polynomial becomes 0. So we just have to think, whenever I will talk about value or zeros of a polynomial, only thing is at that value of x or at that value of the variable, value of polynomial will become equal to 0. Value of polynomial will become equal to 0. Now finding it is very easy. Finding out the 0 of any polynomial is very easy. For example, how can you do it? It can be done better in two simple steps or one simple step. Simple one, whenever you have to find out 0 of a polynomial, make the polynomial equal to 0. Make the polynomial equal to 0 and solve for x. As simple as that. By what I have told, beta, that value of x for which value of polynomial becomes equal to 0. So whenever you have to find out the value of the 0 of a polynomial, or whenever you have to find out zeros of a polynomial, what you will do? Make the polynomial equal to 0 and solve it for x. For example, I have this question over here. Consider the polynomial px equal to 2x plus 1. Find out its polynomial. Let's say we don't know what is p of minus 2. It is not asking. P of minus 2, so we'll put x equal to minus half. Let's say I'm asking you what is the 0 of this polynomial. Simple, beta. Make this polynomial equal to 0. We have got 2x plus 1 equal to 0. You have got 2x is equal to minus 1. X is equal to minus 1 by 2. X is equal to minus 1 by 2. So I can say x equal to minus 1 by 2 is a 0 of polynomial px. And you can also see, beta, value of the polynomial at x equal to minus half will be equal to 2 into minus half plus 1. 2 to 2 got cancelled. Minus 1 plus 1 is what? 0. So you can see at x equal to minus half, the value of the polynomial is also 0. So this is just verification. This is what I have done, beta. I have just done the verification over here. Alright. So zeros of a polynomial means that value of the variable for which value of the polynomial becomes equal to 0. Okay. Chalo bhai. Let's move ahead now. Let's take some good points related to the values or the zeros of a polynomial. First thing, A non-zero constant polynomial has no zeros. A non-zero constant polynomial, that means px equal to a, where a is not equal to 0. A non-zero constant polynomial has no zeros at all. A non-zero constant polynomial has no zeros at all. Say example. For example, let's say, for example, I have taken a polynomial px is equal to 2. I have told you find out its 0. Find out its zeros. So finding out zeros, beta, what I have told you, make px equal to 0. And make polynomial equal to 0. So for finding out 0, we'll make px equal to 0. Polynomial I have given to you as 2. 2 equal to 0. Can it be ever possible? Is it ever possible? No, sir, it is never possible. So remember, any non-zero constant polynomial if I will give, in that case, no matter what value of x you will put, you will never get any zeros, because values of x does not change the value of the polynomial. That is why it is called constant polynomials. Value of polynomial does not change with respect to x, no matter in px equal to 2. Why px equal to 2 is a polynomial? Because x is hidden, power 0. Now if I put x equal to 1, 2, 3, 4, 5, 6, anything I put, value of polynomial will remain 2 only. It will never change. That is why a non-zero constant polynomial has no zeros. Alright. And also remember, a zero polynomial has infinite zeros. Infinite zeros means by zero polynomial is what? Px equal to 0. So its value is already 0. So no matter what value of x I will put, value of polynomial is always 0. So a constant polynomial, if it is a non-zero constant polynomial, there are no zeros for it. And if it is a zero polynomial, there are infinite zeros for it. All values of x will be acting as a 0 for a zero polynomial. And no matter what value of x you will put in a non-zero constant polynomial, it will never be a 0. Alright, next interesting thing is, every real number is a 0 of the zero polynomial, I have told you. Third one, linear polynomial has one and only one zero. Any linear polynomial you will solve it. Suppose say 2x. Linear polynomial px is equal to 2x. Solve it, make 2x equal to 0. X equal to 0, only one 0 you are getting. Suppose another polynomial f of x is, let's say, 3x plus 5. Find out its 0. Make 3x plus 5 equal to 0. X is equal to minus 5 by 3. Again, only one 0. So every linear polynomial will have one and only one 0. Next, consider the polynomial x minus 1. 1 is said to be the 0 of the polynomial x minus 1 or a root of the polynomial equation x minus 1 equal to 0. Ab dekho, simple thing hai beta. I'm just saying what I have told you. X minus 1, if a polynomial is given, if a polynomial px is given to you as x minus 1, and if you have to find out the 0, if you have to find out the 0 of this polynomial, what you will do, make px equal to 0. So make x minus 1 equal to 0, you will get x equal to 1. Simple. You will get x equal to 1. Alright. Ab dekho beta, let's solve some questions. Questions solve karte hain. Once we have done all this beta, now the questions will be very easy. Questions kya hai? First thing, which of the following expressions are polynomials? And in case of a polynomial, write its degree. So first, let us figure out which ones are polynomials and which ones are not polynomials. I can see first one, dekho, power of variable. We know two rules, beta. We know two rules. First is, what are the two rules whenever we have to check for polynomials? Sir, the first rule is power of variable is a whole number. Second, variable division by variable is not allowed. Division by variable is not allowed. Variable should not be in the division. So beta, in the first one, if you will see, power 5, power 3, power 1. Dekho, root 3. We know square root means power half. But dekho beta, this square root is only on 3. This square root is only on 3. That means it is a constant number. So power of variable here is 0 only. any constant number, be it rational or irrational, power of variable will be 0 in that case. So here we can see everywhere the powers are whole numbers, variable is not in the division. So we will say first one is a polynomial. If it is a polynomial degree, highest power is 5. So degree will be equal to 5 for the first one. Second one, I can see negative powers, not a polynomial. Third one, x square is in the division, not a polynomial. Fourth one power x square, power x, power 0. So देखो power is 2, power is 1, power is 0. And 3 by 5, 7 by 3 is equal. Division by number is allowed. Here 5 is in the denominator, you can divide by number, no problem. So fourth one also is a polynomial and its degree maximum power is 2. Fifth one, power 3, power 2. Here power is 3, here power is 2. Root x beta. Root x means power of x is half. Earlier that was root 3. Number can have any power, we don't have any problem. We only look at the powers of the variable. In this case beta, power of the variable is half, and we know half is not a whole number. That is why fifth one also is not a polynomial. That is why fifth one also is not a polynomial. Alright, next question. Identify linear, quadratic, cubic and biquadratic polynomial. ठीक है, easy question. First one, x minus x cube plus x raised to the power 4. Degree 4, we can say biquadratic. Here power 0, power 1, power 3. It will be what beta? Cubic. Minus 7, power 0, x power 1. It means linear. Minus 13, constant number. Power of the variable is 0. That means constant polynomial. Minus 6x square, degree 2. That means quadratic polynomial. And sixth one, minus p by only power 1. That means linear polynomial. So we can say first one is biquadratic, then cubic, linear, constant, quadratic and linear. ठीक है? Alright, so first, second, third. Fourth they have not written over here. Fourth one we can say constant. Minus 30. Alright, next question. Give an example of a monomial of degree 5. Monomial means only one term and degree 5. So chalo, let's say 13 into x raised to the power 5. One term only. Coefficients, they are not separate terms. For separation of terms, in between them there should be addition or subtraction sign. Multiplication and division, they cannot separate two terms. Multiplication means multiply them, they will become a single term. Alright, second, example of binomial of degree 8. So the degree 8 has become now any other term with power of x less than 8. I can say, let's say 6x raised to the power square. Anything. So degree is 8 and it is a binomial. Third one, trinomial of degree 4. So I can say, chalo sir, let's say 4x raised to the power 4. Then 3x cube plus 6, anything. Alright, 3 terms, unlike terms, degree maximum power is 4. Simple. Next question. Alright, so before I move ahead beta, let me tell you about Vedantu's Pro subscription. So in Vedantu's Pro subscription beta, as you all know right now in this situation, the most important thing is your studies, because such a boredom we are having in the pandemic. So in this boredom, there is one thing which we don't want, that is worries. And worries related to our studies, that what will happen to our studies. And that is why Vedantu Pro subscription serves you a very good option beta, because you will be studying with Vedantu subscription at the comfort of your home. No need to go anywhere outside. Also, we do know that there are many students who will be like, who has not tried online education yet, or who are still thinking that, sir, whether I don't know whether online education will be able to help me or not. So that is why we are coming with a promise which no one has ever made. No school, no institute, no one has ever made, and we make Vedantu's improvement promise. In this promise, we give you the full guarantee. We give the full guarantee of your improvement. So we take guaranteed improvement. Guaranteed improvement. We say that you join Vedantu's Pro subscription, you will definitely improve. That is our guarantee. That is our guarantee. And if you do not improve, then what? In that case, you can take your whole course fee back. You can take your whole course fee back. Yes, you heard it right. Will return your whole money if you do not improve in your marks. That is the promise. I'll tell you more in detail about Vedantu's improvement promise, but let's first talk about the features of Vedantu's Pro subscription. So first thing, beta, you will be getting access to unlimited live classes. You can study as many classes as you want, and all the classes are going to be filled with fun and high level quizzes. The students from different parts of the world, so you'll be able to know that where do you actually stand and how much hard work you can do more. Next, interactive replays. So you'll be when you are watching the recording, you'll get to you'll when you're suppose watching the recording and the quiz comes up. So it's not like you are just sitting there, you cannot attempt the quiz. You can also attempt the quiz even while watching the recording, so that you can test yourself how much you have learned even while watching the recording, get the marks and see your name in the leaderboard. Then you'll be getting access to the notes, handwritten notes of master teachers, quality test and assignments, and also you'll be getting doubt solving facility as well. So when you are taking any live class in Vedantu other than master teacher, there will be extra dedicated teacher, there will be more dedicated teachers just to take care of your doubts, and those teachers are best in their subject knowledge. All right, so they'll make sure that you do not go without your doubts being solved. That is our policy. We know that no doubt is a small doubt, no doubt is a wrong doubt, no doubt is say a waste doubt. All doubts are important. That is why we'll make sure with the help of the teachers cloud's doubt solving facility that each and every doubt of yours will be solved whenever you get it. All right, beta. So the link and also along with that we have free unlimited micro courses. So once you will take this Vedantu Pro subscription, it is not like we'll be only teaching you a chapter only once. Suppose polynomial I have taught you now. Now throughout the year I'll not teach you. Only during the before the examination I'll just do the revision like that. No. In Vedantu Pro subscription, with the help of micro courses, that is chapter specific course, if you suppose you feel the need of reading the chapter one more time, suppose you felt ki sir I have some say difficulty with the topic polynomials and I want to read its micro courses again, I want to read that chapter again. So what you can do is you can go for the micro courses. With the help of micro courses you will be able to study the whole chapter. You can study any chapter as many times as you want, and also you can do your revision with the help of crash courses as well. So registration for Vedantu's Pro subscription is mentioned in the description box of this video, as well as in the pinned comment. The coupon code is GPE Pro to get you 10% off. Yes, the coupon code GPE Pro will give you extra 10% off. So please don't miss out on this opportunity and get the best out of it. All right, let's go for the next question. Let's see what is the question saying. Now this question says P of x is equal to x cube plus x square minus 9x minus 9. Find P0, P3, P minus 3 and P minus 1. That means values of the polynomial we have to find out. What do you conclude about the zeros of Px is 0, a polynomial of P of x? Okay, let's find it out. So we know P of x is equal to x cube plus x square minus 9x minus 9. Let's put the different values of x. First we have to find out P of 0. In place of x, whenever you have to find out the value of any polynomial, whatever value is given, wherever that variable is present in that place, write the value of the variable as the given number. So here given number is 0. Wherever I will see x in the polynomial, I will write 0 over there. So I've got 0 cube plus 0 square minus 9 into 0 minus 9. Everything is 0 except this minus 9. Value is minus 9. Second, P of 3. So it will be 3 cube plus 3 square minus 9 into 3 minus 9. So 3 cube is 27 plus 3 square is 9. Minus 9 into 3 is minus 27 minus 9. So you can see everything got cancelled. P of 3 is equal to 0. P of minus 3. So we can say P of minus 3 will be minus 3 cube plus minus 3 square minus 9 into minus 3 minus 9. Minus 3 cube is minus 27. Minus 3 square, power is even, the answer will be positive. Plus 9, negative into negative is positive, 9 3s are 27 and again minus 9. Again you got beta, everything got cancelled, answer is 0. And the last one, p of minus 1. So p of minus 1 will be equal to minus 1 cube plus minus 1 square minus 9 into minus 1 minus 9. So minus 1 cube is minus 1, minus 1 square is plus 1, minus 9 into minus 1, negative into negative is positive, so plus 9 and then minus 9. Again everything got cancelled, here also the answer is 0. So beta, you can see, what do you conclude about the zeros of the polynomial? So we can see p of 3 is equal to 0, p of minus 3 is equal to 0 and p of minus 1 is equal to 0. So I can say x equal to 3, minus 3 and minus 1 are zeros of polynomial px. Understand beta, only for a linear polynomial there is only one zeros. As the degree increases, the number of zeros for a polynomial can increase. All right. So here the degree is 3, so that is why we have got 3 zeros. Is a 0 a polynomial of px? No sir. At 0, at x, p of 0 is minus 9. That is why 0 is not a polynomial. So I can say 0 is not a 0 of px. ठीक है बेटा, next question. Verify that 2 and minus 3 are the zeros of this polynomial. So how do I verify? How do I verify that whether x equal to 2 and minus 3 is 0 or not? So I know beta that if x equal to 2 is a 0 of px, then I know p of 2 will be equal to 0. That is what na? If p of 2 is equal to 0, then only I can say x equal to 2 is a 0 of the polynomial px. So let's find out the value of this polynomial at x equal to 2. So it will be 2 square plus 2 minus 6. 4 plus 2 minus 6, which is 6 minus 6, which is equal to 0. So p of 2 is equal to 0. That means I can say yes sir, x equal to 2 is a 0. Similarly, p of minus 3. So it will be minus 3 whole square plus minus 3 minus 6. So minus 3 whole square is minus 3 whole square is 9. Negative number square also is positive only. Plus minus 3 is minus 3 minus 6. So you are getting 9 minus 9. So I can say p of minus 3 again is equal to 0. So I can say x equal to minus 3 is a 0 of px. Okay? Alright? This is how easily we can do the verification. Yeah, first session is very easy. Next question. Find the zeros of the polynomial. These polynomials you have to find out the zero. So I have told you, whenever we have to find out the zero, make polynomial equal to 0. So px is given as x minus 5. For 0, make px equal to 0. That means in place of px I can write x minus 5 equal to 0. So x equal to 5. X equal to 5 is a 0 of the polynomial px. Second, p of x is equal to 3x plus 1. Make px equal to 0. So make 3x plus 1 equal to 0. That means 3x is equal to minus 1. So I can say x is equal to minus 1 by 3. And the last one, px is given as suppose ax. Alright, where a is not equal to 0. So make ax equal to 0. I can say x is equal to 0 upon a. Beta, I know a is not equal to 0 given over here. That means I can do division by the a. Because if a becomes 0, in that case division will not be possible. But since they have clearly told that a is never equal to 0, so this division will always work, and 0 upon anything is 0 only. So x equal to 0 is the polynomial is the 0 of the third polynomial. Alright. So finding out the 0 of the polynomial is very easy. Make the polynomial equal to 0. Alright. Next question. If 2 and 0 are the zeros of the polynomial f of x, then find the values of a and b. So beta, I know, yaar, if 2 and 0 are the zeros, so beta, I know that f of 2 will be equal to zeros and f of 0 will also be equal to 0. F of 2 will be equal to 0 and f of 0 will also be equal to 0. ठीक है? Solve these two equations and find out the value of a and b. I actually thought that I will solve this question, but now I am thinking, why not give it as a homework question? it would be much better. It would be much better if I give you this as your homework question. Yes or no? So this is your homework question. Do let me know what will be the value of A and B, and you know where do you give me your answers. You'll give me your answers in the comment section. Alright. So I'll wait for all of your answers, beta. Do let me know what is the values of A and B. Alright. Chalo, let's move ahead. So with this, we have finished our topic. Let's move ahead now. Alright. So as I was telling you about Vedantu's Pro subscription, actually earlier this was the zeros I was thinking, but now it is very easy, so you can do it on your own. But that is the homework question. That is a very interesting question. All right, both the questions are there. That question is very important. This you can do it easily. Okay. What? Find out the value of P1, P2 and P3. Just find out their values, and from these values you'll get to know what will be the zeros of this polynomial. All right, out of these three, which one will be the zeros of the polynomial? Very easily, just for your practice. This is just a practice question. I'm changing this. This is just a practice question, but that is my homework question. Alright. Now, as I have told you, you can join Vedantu's Pro subscription by clicking on the link mentioned in the description box. For example, let's say this is the video we have reached. Alright. Now come in the description box. Here you can see in the description box you have Vedantu, subscribe to Vedantu Pro now. Just click on this link. Once you'll click on this link, you'll reach to this page. Now, if you want to change your grade, click on edit. You can change your grade also or your board also. Once you're done, click on get started. Then you have three courses: Pro Lite, Pro Classic, Pro Plus. So Pro Lite, beta, in this you have got all the basic features: online classes, online classes, test series, assignments, notes and doubt solving during class. In Pro Classic, you get one extra feature, that is doubt solving on the mobile app. And in Pro Plus, you get one more extra feature, that is personal mentor. So personal mentor, you can think of it them as your teacher, coach, guide, supporter, motivator. Any doubt you have, academic, non-academic, you can always reach out to them and they'll always help you. So they are like first point of contact for any problem you are facing. So you can see the prices for all the three courses. Now you can choose to join any of these courses which you want according to the features given. Suppose if you are new and you want to try this course, ki sir, yeah, I want to try it once. You can just click on any one and click on try for 1 month. You can click on try for 1 month, try it for 1 month. Once you have started, ki, haan sir, now I know sir, I will do better, and I'm very sure you will be satisfied after 1 month. Once the month is over, you can click on buy complete course. Once you'll buy the complete course, beta, throughout the year, you will be with us and will take care of your whole syllabus. Alright, also, when you're buying the complete course, suppose the fee is altogether too much, you can also go for EMI option as well. So in that you will be paying in installments, so that will not be financial burden as well, ki haan, too much altogether. Alright, theek hai bacha, any other doubt you have, you can clearly see here frequently asked questions are given. You can go through them as well. Okay, so beta, this is all in today's class. Also, one more thing, I want to talk to you about Vedantu's improvement plan promise, that is VIP. So simple beta, we take the full ownership of your studies. Let me tell you very clearly, if you do not improve, we are taking guarantee of your improvement, guaranteed improvement. And if you do not improve without any questions asked, we will return your whole fee. Get your whole course fee back, no question asked, if you do not see any improvement after the end of 1 year. So whatever you have taught, that will be free of cost, no need to pay anything. At the end of the 1 year, you don't see any improvement, take the whole course fee back. Alright, so remember beta, there will be, for this promise, you also need to be say a long-term student. That means you need to be with us in that, which I have told, buy a complete course. You should be our long-term student. You should buy the complete course, so that we can take the guarantee now only when you are with us together. For the whole year you are studying somewhere else, and only for the last month if you are coming, in that case the guarantee cannot be there. We'll try our best, but guarantee will be there for those students who are throughout there with us. Also, you need to have at least 75% of the attendance of the classes and 75% of the test you should complete. Alright, so you need to be active as well. You should attend the classes. Rest we will take care of. Alright beta, so this is all in today's class. Thank you so much for joining the session. You can see the batch starting dates. Alright, so please join quickly. Thank you so much. I hope all of you enjoyed the class. Please don't forget to like the video, share the video, and subscribe to the channel. Thank you so much guys for coming to the session and make this session a really great session. I hope all of you enjoyed it. Please don't forget to write the answer of your homework question in the chat box or in the comment section, because I'll be waiting for it. Alright, so thank you so much guys. I'll see you soon. I'll meet you soon in the next class. Till then, bye bye. Sayonara, Khuda Hafiz to all of you. Bye bye.